centimeters. To find out the area of a square, you multiply the length of any two sides. Therefore, the area of the square with side 2 centimeters is equal to 4 square centimeters. Similarly, the area of the square with side 3 centimeters is equal to 9 square centimeters. And the area of the square with side 4 centimeters is equal to 16 square centimeters. Look at the numbers obtained after calculating the area of each square. These numbers are 4, 9, and 16. What do you think is a special feature of these numbers and other such numbers? How do you calculate the area of a square with each side as large as 64 centimeters? Think of the numbers that you obtained as squares. For example, 4. You can express 4 as 2 multiplied by 2, which is equal to 2 square. Similarly, 9 can be expressed as 3 multiplied by 3, which is equal to 3 square. In the same way, 16 can be written as 4 square. Therefore, if a natural number n is such that n is equal to m square, where m is another natural number, then n is called a square number or a perfect square number. Let us try to calculate the square of 32. Since 32 is equal to 30 plus 2, 32 square is equal to 30 plus 2 whole square. This can be expressed as 30 plus 2 into 30 plus 2. Using the distributive law, you can write it as 30 into 30 plus 2 plus 2 into 30 plus 2. This is equal to 30 square plus 30 into 2 plus 2 into 30 plus 2 square. When solving the equation, you get 1024. Now you can solve the original problem. Find the area of the square with each side equal to 64 centimeters. The area of a square is equal to the square of the length of its side. Each side is equal to 64 centimeters. Therefore, the area is equal to 64 square. This can be written as 60 plus 4 whole square. You can solve the equation by expanding it as 60 plus 4 into 60 plus 4. This is equal to 60 into 60 plus 4 plus 4 into 60 plus 4, which, when simplified, is equal to 4096. Hence, the area of the square with each side 64 centimeters is equal to 4096 square centimeters. Square numbers contain some interesting patterns. One such pattern is the Pythagorean triplet. Pythagorean triplet is formed by 3 natural numbers, a, b, and c, satisfying the relation a square plus b square is equal to c square. Let's look at an example of a Pythagorean triplet. Suppose you have 3 square numbers, 9, 16, and 25. You know that 9 plus 16 is equal to 25. This can also be written as 3 square plus 4 square is equal to 5 square. Thus, the numbers 3, 4, and 5 form a Pythagorean triplet. Another example of numbers that form a Pythagorean triplet is 5, 12, and 13. Here, 5 square plus 12 square is equal to 169, which is equal to 13 square. As 5 square plus 12 square is equal to 13 square, the numbers 5, 12 and 13 form a Pythagorean triplet. You can use a general formula to find a Pythagorean triplet. For any natural number n greater than 1, 2n whole square plus n square minus 1 whole square is equal to n square plus 1 whole square. Therefore, the numbers 2n, n square minus 1 and n square plus 1 form a Pythagorean triplet. This is true for any natural number n greater than 1. Let us use this formula to find a Pythagorean triplet in which one number is 8. Consider 2n is equal to 8, which implies that n is equal to 4. Therefore, the numbers in the triplet are 2 into 4, 4 square minus 1, and 4 square plus 1. On simplification, you get the numbers 8, 15, and 17, which form a Pythagorean triplet. You can also solve this problem by considering n square minus 1 is equal to 8. This implies that n square is equal to 8 plus 1, which is equal to 9. 9 can be expressed as 3 square. Therefore, you can say that n square is equal to 3 square, and accordingly, n is equal to 3. Thus, the numbers in the Pythagorean triplet are 2 into 3, 3 square minus 1, and 3 square plus 1. Simplifying these, you get 6, 8, and 10, which form a Pythagorean triplet. Now consider n square plus 1 is equal to 8. This implies that n square is equal to 8 minus 1, which is equal to 7. But 7 is not the square of any natural number, so we cannot find the value of n. Therefore, we get two sets of Pythagorean triplets in which one number is 8. Here is a table with numbers from 1 to 20 and their respective squares. Note that in the square numbers, the units place is 0, 1, 4, 5, 6, or 9. Therefore, you can say that no square number ends with 2, 3, 7, or 8. Also, if the units place of a number is 0, 1, 4, 5, 6, or 9, then the number may or may not be a square number. However, a square number always ends in 0, 1, 4, 5, or 9. You can use a pattern to find the squares of some special kinds of numbers. Observe the following squares. 1 square is equal to 1. 11 square is equal to 1, 2, 1. 111 square is equal to 1, 2, 3, 2, 1. Similarly, the square of 1111 is equal to 1, 2, 3, 4, 3, 2, 1. You can write the square of 11,111 by writing numbers from 1 to 5 and then writing reverse counting from 4 to 1. Thus, you can easily find the square of a number with its digits as 1. First, count the number of digits in the number, then write the counting numbers from 1 to that number and write the reverse counting up to 1. You can add consecutive odd numbers by using a pattern. The first odd number is 1, and its sum can be written as 1 square. The sum of the first two consecutive odd numbers, 1 and 3, is 4, that can be written as 2 square. Similarly, the sum of the first three consecutive odd numbers, 1, 3, and 5 is 9. That can be written as 3 square. Observe this pattern. The sum of the first odd number is 1 square. The sum of the first two consecutive odd numbers is 2 square. And the sum of the first three consecutive odd numbers is 3 square. Thus, it can be concluded that the sum of the first n odd natural numbers is n square. You can use a pattern to multiply two consecutive even or odd numbers. Here's an example. Take the product of two consecutive odd numbers, 7 and 9. 8 lies between 7 and 9, so you can write 7 as 8 minus 1 and 9 as 8 plus 1. This is equal to 8 square minus 1 square. On simplifying the numbers, you get 63. Therefore, 7 into 9 is equal to 63. Consider one more example. 12 into 14. You can write 12 as 13 minus 1 and 14 as 13 plus 1. This is equal to 13 square minus 1 square. On simplification, you get 168. Therefore, the product of two consecutive odd or even numbers can be expressed as the square of the number between them minus 1. Another interesting pattern is that of triangular numbers. Triangular numbers are those numbers whose dot patterns form right-angled triangles. Some of these numbers are 1, 3, 6, 10, and 15. Now, add two consecutive triangular numbers, 1 and 3. The sum of 1 and 3 is equal to 4, which is 2 square. Similarly, 3 plus 6 is equal to 3 square. 6 plus 10 is equal to 4 square. And 10 plus 15 is equal to 5 square. Therefore, the sum of two consecutive triangular numbers is a square number. You can express the squares of odd numbers as the sum of two consecutive natural numbers except one. Let's see how. Consider the odd number 3. Its square is equal to 9. 9 can be written as 4 plus 5. Here, 4 and 5 are consecutive natural numbers. Now, take the odd number 5. Its square is 25. This can be written as 12 plus 13. Here, 12 and 13 are consecutive natural numbers. Let's look at the general formula for doing this. If n is an odd number greater than 1, then n square is equal to n square minus 1 divided by 2 plus n square plus 1 divided by 2. Now, use this formula to express the square of 9 as a sum of two consecutive natural numbers. 9 square is equal to 81. Therefore, using the above formula, 81 is equal to 81 minus 1 divided by 2 plus 81 plus 1 divided by 2. On simplification, you get 81 is equal to 40 plus 41. Here, 40 and 41 are two consecutive natural numbers. Let us now learn how to count the non-square numbers between the squares of two consecutive numbers. Consider the numbers 1 and 2. 1 square is equal to 1 and 2 square is equal to 4. Now you need to count the numbers between 1 and 4. The numbers between 1 and 4 are 2, and 3. Therefore, you have two non-square numbers between 1 square and 2 square, and 2 is the double of 1. Now consider one more pair of numbers, 3 and 4. 3 square is 9 and 4 square is 16. The numbers between 9 and 16 are 10, 11, 12, 13, 14, and 15. Therefore, you have 6 non-square numbers between 3 square and 4 square. 6 is the double of 3. The conclusion is that there are 2n non-square numbers between n square and n plus 1 whole square. Here's a quick summary of all that the topic covered. If a natural number n is such that n is equal to m square, where m is also a natural number, then n is called a square number or a perfect square.